Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in this video we will solve examples number 1 to 5 of practice set 1.3, which are based on definition of similar triangle and test of similar triangle from the chapter Similarity. First example, in the given figure, angle ABC is 75 degree, angle EDC is also 75 degree. State which two triangles are similar and by which test. Also write the similarity of these two triangles by a proper one-to-one correspondence. So here let us consider triangle ABC and in triangle EDC. So in triangle ABC and triangle EDC. In these two triangles, now if you see here, these two triangle ABC and triangle EDC, angle ABC and angle EDC is given as 75 degree. So major angle ABC is congruent to angle EDC, each 75 degree. Each angle is 75 degree. Now in this big triangle ABC, angle ACB and angle ACB is congruent to angle ECD. This is angle C is the common angle in both the triangle. Angle C is common in the angle C is in big triangle as well as in the small triangle. So it is a common angle. So angle ACB is congruent to angle ECD, common angle in both the triangle. Therefore, these two triangles, triangle ABC and triangle EDC, two angles of one triangle is congruent to corresponding to angles of the another triangle. So these two triangles are similar by angle test, angle and common angle test of similarity. So triangle ABC is similar to triangle EDC by AA test of similarity. AA test of similarity. Therefore, one-to-one correspondence. One-to-one correspondence of this both the triangle is same. Vertex A goes to E, B goes to D, and C is the common, so C goes to C. So vertex ABC corresponds to A goes to E, B is congruent to 75, that is D, and C is the common. So one-to-one correspondence is ABC corresponds to EDC. Second example, are the triangles in adjoining figure similar? If yes, by which test they are similar? Now let us consider in triangle PQR and triangle LNN. If you observe these two triangles, the length of sides of both the triangles are given. So this example is based on the sides of the similar triangle. So here we will take the ratios of the corresponding sides of similar triangle. So here ratio PQ side PQ upon corresponds to side LN, that is LN, which is equal to PQ is equal to 6 upon LN is 3, which is equal to 3 1s are 3, 3 2s are 6, that is 2 upon 1. Then QR corresponds to MN, so side QR upon side MN is equal to QR is 8, MN is 4, so 8 upon 4, which is equal to 4 1s are 4, 4 2s are 8, that is 2 upon 1. And side PR corresponds to side LN, so PR upon LN, PR side PR upon side ln, which is equal to side PR is 10 upon LM is 5, 10 upon 5, 5 1 is 5, 5 2 is 10, 2 upon 1. If you see the all three ratios, that is 2 upon 1, 2 upon 1, 2 upon 1, all three sides are, that is ratio is equal, that is side PQ upon LM is equal to QR upon MN is equal to PR upon LN. Sides are in proportion, which is equal to 2 upon 1. So therefore, triangle PQR is similar to triangle LMN by side-side test of similarity, SSS test of similarity. Third example, as shown in the figure, two poles of height 8 meter and 4 meter are perpendicular to the ground. If the length of the shadow of smaller pole due to sunlight is 6 meter, then how long will be the shadow of the bigger pole at the same time? So let us assume here, let the length of the shadow of the bigger pole be x meter. Here AC and PR are the height of the poles, and QR and BC, these are the BC and QR are the length of the shadow of two poles respectively. Now here, as this vertical pole and their shadow forms the similar figure as vertical poles and their shadows form similar figure. They form the similar figure. Hence, triangle ABC is similar to triangle PQR. Therefore, triangle ABC is similar to triangle PQR. When two triangles are similar, by definition of similar triangle, AB upon PQ, AB upon PQ is equal to BC upon QR, BC upon QR is equal to AC upon PR, AC upon PR. Corresponding sides are in proportion. That is, corresponding sides of similar triangle are in proportion. Now, here length of side PR, QR, AC and BC are given. So, we will consider these two ratios. So, BC is equal to X upon QR is 6, X upon 6 is equal to AC 8 upon PR 4, that is 8 upon 4. Therefore, cross multiply here, X into 4 is equal to 8 multiplied by 6, 8 into 6. Therefore, X is equal to 8 into 6 divided by 4. 4 1s are 4, 4 2s are 8. So, 6 2s are 12 meter. X is 12 meter. That is the length of shadow of the bigger pole is, so length of shadow of bigger pole is 12 meter. In triangle ABC, AP is perpendicular to BC, BQ is perpendicular to AC, such that B dash C and A dash 2 dash C. Then you have to prove that triangle CPA is similar to triangle CQB. If AP is 7, BQ is 8, BC is equal to 12, you have to find AC. Now here, let us consider in triangle CPA and triangle CQB. Triangle CQB. In these two triangles, angle APC, is congruent to angle BQC. So see here, both the triangle APC and BQC, both the triangles are right angle. So angle BQC, each 90 degree. They are congruent. Also, this angle C, that is angle ACP is congruent to angle BCQ, which is common angle in both the triangles. It is a common angle in both the triangle. Hence, two angles of one triangle are congruent to corresponding to angles of another triangle. So, this two triangles, therefore, triangle CPA is similar to triangle CQB by AA test of similarity. They are similar by AA test of similarity. Therefore, you can write now one-to-one correspondence. Therefore, CP upon CQ is equal to PA upon QB is equal to CA upon CB. That is, corresponding side of similar triangle are in proportion. Here CP upon CQ first two, then PA upon QB is equal to CA upon CB. Now the sides which are given, we will choose those corresponding sides, and which we have to find AC here. So PA is given. You consider these two ratios. Therefore, PA is equal to 7. Then QB is equal to 8. 7 upon 8. CA we have to find, and BC, that is 12. BC is equal to 12. Therefore, 8 into CA is equal to 7 into 12. Therefore, CA is equal to 7 into 12 divided by 8. 12 sevens are 84 upon 8. 84 upon 8. Divide now. 8 ones are 8. 8 ones are 8. 0 and 8 fives are. So CA, that is AC, is equal to 10.5 units. AC is equal to 10.5 units. Example, in trapezium PQRS, side PQ is parallel to side SR. AR is equal to 5 times AP and AS is equal to 5 times AQ. Then we have to prove that SR is equal to 5 times PQ. Now let us consider here in trapezium PQRS, PQ is parallel to SR and line PR is the transversal. Therefore, angle QPR is congruent to angle SRP. These two angles are congruent since they are alternate angles. So by alternate angle test, the two parallel lines are intersected by transversal. Alternate angles are congruent. Therefore, that is angle QPA is congruent to angle SRA. Statement number 1. Now let us consider in triangle PAQ, and triangle RAS, angle QPA is congruent to angle SRA. So from statement number 1, which we have proved it, alternate angles. Now this angle Angle PAQ is congruent to angle RAS. These are vertically opposite angles. So vertically opposite angles are congruent. So angle PAQ is congruent to angle RAS. Vertically opposite angles. Therefore, this triangle PAQ and triangle RAQ, since two angles of one triangle are congruent to corresponding to angles of another triangle, so these two triangles are similar. Therefore, triangle PAQ is similar to triangle RAS by angle test of similarity. Therefore, the corresponding sides of similar triangle are in proportion. Therefore, PA upon RA is equal to AQ upon AS, which is equal to PQ upon RS. Corresponding side of similar triangle are in proportion. Now here, what is given here? AR is equal to 5. AP, which is given. Therefore, AP upon AR is equal to 1 upon 5. Therefore, that is here PA upon RA is equal to 1 upon 5. Just interchanging the vertex. PA upon AR. So this is given. You have to find PQ, relation between PQ and RS. Therefore, the ratio 1 upon 5 is equal to PQ upon RS. That is, therefore, RS is equal to 5. That is, RS is equal to 5 PQ. Hence, we have proved it. RS is equal to 5 times PQ.